then iq into minus iq means minus I square q square. If I put the value of I square minus 1, then that will be plus a plus b whole square. First of all, on the rough space, let us discuss. Imaginary part is 4i. Actually, in this part there is 2abi. Now let us think. A, B are so chosen that difference of the squares of the two, that is a square minus b square or b square minus a square, will be the real part. Next two sums I have taken. First one, resolve into factors this one. From the knowledge we have gained earlier, we know that a square plus 1, that is sum of two square numbers, that cannot be resolved into factors. But after knowing the imaginary number, that is I square equal to minus 1, where I is imaginary unit of complex number, or we also call that unit imaginary number. Applying that concept, we can resolve into factors this one. As we have learned, I square equal to minus 1, a square minus of minus 1, that means a square minus I square. Now automatically we get the form a square minus b square. Therefore, we apply that identity. The identity of a square minus b square is a plus b into a minus b. I have applied that. Now we see that this is product of two factors. Then next sum, 1 plus a square, 1 plus b square. Product of two factors. First one is 1 plus a square, second one is 1 plus b square. We have to express that as sum of two squares. We can solve this sum using the idea we have learnt in the lower classes, but if I apply I square equal to minus 1, then it will be rather easier. For that, first I write this 1 minus I square a square, 1 minus I square b square first. See the steps, very interesting. Then 1 plus IA, 1 minus IA, 1 minus IB into 1 plus IB. Now I take these two first. 1 plus IA, 1 plus IB. I close them using parentheses. 1 minus IA, 1 minus IB. Now we multiply these two, next these two. I take the real part first, 1, then IA into IB means I square AB minus AB, then I into A plus B, and for this one, 1 plus I square AB minus AB, minus IA into minus IB means plus I square B AB, I square minus 1, that is why this one, plus I into minus A minus B. In both cases, I have expressed in the standard form. Now, I write minus A taking outside means 1 minus AB plus I into A plus B, one minus AB minus I into A plus B. Thus we get the form P plus IQ into P minus IQ. The result will be 1 minus AB whole square P square, then IQ into minus IQ means minus I square Q square. If I put the value of I square minus 1, then that will be plus A plus B whole square. Finally, we see this is of the form P square plus Q square expressed as sum of two squares. Remember that here AB are real numbers. I mentioned here AB are real numbers. Therefore, these two sums have been solved. Theories are there about complex numbers. Now I am going to start those theories. First of all, we have to find the square root of a complex number. I have taken A plus IB. To find the square root, what we do? Let root over A plus IB be, already we have discussed, it has been discussed earlier, that any root of a complex number is a complex number. Also, any power of a complex number is a complex number. Using that idea, I have taken root over A plus IB, that is square root of A plus IB is equal to x plus IB. Now, since there is square root, we first square both sides. Square it. Left hand side will be A plus IB. Right hand side will be x plus IY whole square. If we simplify, it will be x square minus y square plus 2I xy. Equating real and imaginary parts. X square minus y square, that is the real part on the right side, that will be equal to A, and 2xy equal to B. Thus, we get two equations involving two variables x and y. Now, if the values of AB be given, we can solve easily the values of for the values of x and y. Solving, we will have the values of x and y, and hence we can find the square root of a plus ib. Students, you note here, I have not solved for xy. Since a, b are in unknown form, I have not shown the process of solving. Actually, after getting these two equations, x square minus y square equal to a value, 2xy is equal to another value, we can follow any way. One way will be, we can find the value of x square plus y square whole square, applying the identity a plus b whole square equal to a minus b whole square plus 4ab. Also, the other way is, we can express from this equation y in terms of b and x and put their value in the first one. Then we will get a fourth degree equation involving x, and from that, though it will be complicated, we can find the value of x and y. I have not shown here the process of solving. Now, to find the square root of a given complex number, we can follow this way. I say this is theoretical way, and also using observation or observing, we can find the square root. Actually, in case of observation, we write the given complex number in a square form first. Then, if we can express a given complex number in the form of, say, x plus iy whole square, then the square root will be plus minus x plus y. I am going to discuss few sums. First sum is 3 plus 4i. To find the square root of number 1, 3 plus 4i. Also, I say trial method. First of all, on the rough space, let us discuss. Imaginary part is 4i. Actually, in this part, there is 2abi. Now, let us think. A, B are so chosen that difference of the squares of the two, that is a square minus b square or b square minus a square, will be the real part. Now, 4i can be written as 2 into 2 into I. If I take as this as a and this as ib, that means b equal to 1. Then a square minus b square will be equal to 2 square minus 1 square. On simplification, it will be 3. This is the method of thinking. Therefore, first I write in this form 2 into 2 into I. Then this is 4 minus 1. I will suggest learners, students, to do this thing in the rough space, and after this step you do this one. then I can express easily 2 square plus I square plus 2 into 2 into I. That means a square plus b square plus 2ab form. Thus I have expressed a plus ib in the form of x plus iy whole square. Therefore, required square root plus minus 2 plus I. Sorry, 2 plus I. Be careful, you must mention plus minus of 2 plus I. Then I take another sum 5 minus 12I. Let us do the rough work. 12I, in which 2abi is there. That means 2 into 6 into I. 2, 6 is there, and we have to keep in mind that difference of squares of two numbers will be 5. Now, if I take as 3 into 2I, then its square is 9, its square will be 4I square. That means minus 4. That means 9 minus 4, that will give you 5. Therefore, we write this 9 minus 4 minus 2 into 3 into 2I. Then 9 is 3 square plus 2I whole square minus 2 into 3 into 2I. Note this, you must be careful how we think. A square plus b square minus 2ab. This part is very important. Therefore, this is 3 minus 2I whole square. Therefore, square root of 5 minus 12I, actually roots are plus minus 3 minus 12. Next, I have taken another example. Number 3, I. We have to find the square root of I. First of all, we note that real part is absent. That means real part is 0. Also, we note that imaginary part is not of the form 2ab. For that, you see the step I am following. 2I. Now, this is 0 plus 2 into 1 into I. I have written this 2I, imaginary part, in the form 2abi. Here, 2abi, A is 1, B is also bi, that means I. That means b is 1. Now this 0 can be written as 1 minus 1, a, b both are 1, plus 2 into 1 into I. It is minus 1 means I square. Therefore, half into 1 square plus I square plus 2 into 1 into I. That is equal to 1 by root 2, 1 plus I whole square. I suggest you note these things. Finally, I have expressed the given complex number as a square form. Therefore, square root of I r plus minus 1 by root 2 into 1 plus I.